Now, this is a basic example of this chapter. Okay. Here, cost of one notebook is 30. Cost of two notebooks is 60. Cost of three notebooks is 90. Now look at here. We can write 60 as 2 into 30. Right? Again 90 as 3 into 30. Similarly, cost of 4 notebooks is 120. So again we can write it as 4 into 30. Similarly, here 150 as 5 into 30, 160 as 6 into 30 and 210 as 7 into 30. Which means cost of 5 notebooks is 5 into 30, which is 150. Again, cost of 6 notebooks is 6 into 30. Similarly, cost of 7 notebooks is 7 into 30. So in this manner, you can tell that you can write here cost of X notebooks is X into 30, which is 30X. Now look at this expression. Here X is our variable and 30 is our constant. This type of expression called algebraic expression, which means an expression where you can combine the variable and constants with the sign of fundamental operations, which are 4 operations: plus, minus, multiplication and division. So here, this is our fundamental operation. By this operation, with this operation, we can combine constants with variables. So this type of expressions are known as algebraic expressions. Now suppose cost of one notebook is 31. Cost of two notebooks is 61. Cost of three notebooks is 91. Okay? Again 121. Cost of 5 notebooks is 151. 6 notebooks 181 and 7 notebooks 211. Then cost of X notebooks is 30X plus 1. Look at here. You can write 31 as 30 plus 1. 61 as 2 into 30 plus 1. Right? Again 91 as 3 into 30 plus 1. Similarly, cost of X notebooks is 30 into X plus 1. Here, this is also an algebraic expression. But in this expression, we have two terms. First one is 38 and second one is 1. Here, the variable is X, but the constants are 30 and 1. Okay? Now, consider some algebraic expressions. X squared plus 3x plus 1. X cube plus 4c y plus 3. Now, all are algebraic expression because all these expressions have combination of constants and variables with with sign of fundamental operations, which is here in this expression our fundamental operation is plus, right? Here x is our variable. In this expression x is our variable and this expression has three terms. First term is x square, second term 3x and the third term is 1. Now here we can write x square as 1 into x square, which means 1, 3 and 1. Also we can write 1 as 1 into x to the power 0 because we know that any rational number with power 0 the value is 1, right? So we can write here 1 into x to the power 0. Now look at this expression. Here 1 is the coefficient of x square of this term. 3 is the coefficient of x and 1 we can call 1 as constant term or we can call 1 as the coefficient of x to the power 0. So don't write here x to the power 0 and we can say 1 as constant term. Okay. Now come to your next expression, which is x cube plus 4. Now in this expression we have two terms. First one is x cube and second one is 4. Again we can write here 1 into x cube, which means 1 and 4 are the constants and 1 is the coefficient of this term x cube and 4 is our constant term of this expression. Constant term 4. Next, in this expression our variable is y. Why? Because y can take any value, which means we can assume any value for y, any rational number. Okay? But 3 is a fixed rational number or natural number. That's why here y is our variable but 3 is our constant term. Next here our variable is x and y or xy. Look at the first term. Here in this expression, again we have three terms, right? First one xy square, second one xy and third one is 1. Now again we can write 1 into xy square, 1 into xy plus 1. Where 1 is our constant term. And here the coefficient of the first term xy square is 1 and also the coefficient of the second term, which is xy, also 1. But this is an expression where the variable is xy. Now look at this algebraic expressions. Here in our first expression we have only one term, which is 3x square. Here the variable is x and the constant is 3. Also we can call 3 as the coefficient of x square. Now in our next term, next expression, here also we have two terms, 5x and 1. Now here 5 and 1 are the coefficients, and this is an expression or algebraic expression of variable x. Now in this term, 5 is our coefficient of x and 1 is the constant term of this expression. Next, here in this expression we have three terms, 3x square, 5x and 3. Here 3, 5 and again 3 are the constants and x is the variable. Now 3 is the coefficient of x cube, 5 is the coefficient of x and 3 is our constant term. Next expression, it has also three terms, 2x square, 5x and 2. Now here also 2, 5 and 2. These are the constant term and x is our variable, right? Now here 2 is the coefficient of x square, 5 is the coefficient of x and 2 is the third constant term. Constant term of this expression, of this algebraic expression. Now look at first expression. Here we have only one term. So those expressions or those algebraic expressions which have only one term, this type of expressions are known as monomial. In our next expression, we have two terms, right? One is 5x and one is the constant term 1. So this type of expression known as binomial, because here we have two terms. Next here, this expression has three terms, right? 1, 2, 3. Those expressions have three terms known as trinomial. Next, you can also call this expression as trinomial because here also we have three terms, 2x square, 5x and 2. Here we have to identify the variables. Okay? So look at here. M is not a fixed point, right? We can assume any rational number or any rational value in place of m. So m is a variable. Next, 15. We know that 15 is an integer, right? Which means 15 is a fixed point. So this is not a variable. Next, minus 12. Minus 12 is also a negative integer, right? So this is also a fixed value, minus 12, which means this is also not a variable. Next, again is a variable, right? Because you can assume any value, any rational value in place of a. Now look at here. Here 10xy is combination of the constant term 10 and the variable xy. So we can write it as 10 into xy. Right? Next, 25a square b. So here 25, this is an algebraic expression, right? Because this is a combination of constant term and variable. So here the constant term is 25 into variable is a square B. Next, here can write 9 into x square y square, or can write it as xy square, because we know that a square into b square equals to ab whole square from the chapter exponents. Next, look at here, AB into AB into AB into AB, which means here AB is multiplied with itself 4 times. How many times? 4 times, right? So we can write it as AB to the power 4. We know that here AB is called base and this 4 is called power or exponent or index, right? So the exponential form, which means the exponential form of this expression is AB whole to the power 4, and AB is the base and 4 is our power or index. Now look at here, our first expression is 5x cubed minus 7x plus 5. So here in this expression our constant term is 5, right? Now coefficient of the term x cubed is 5 and coefficient of x is minus 7, not 7. Here we have to write the coefficient of x is minus 7. Now number of terms of this expression. Here we have 5x cubed first term, second term minus 7x, and the third term is 5, which means this expression has 3 terms. So write here 3. Next, highest power of the variable. Now what is this? Highest power of the variable. Look at here. In this expression, x is our variable, right? Now, first term, the power of x is cubed. We know that here x is called base and 3 is called index or power, right? So here in this expression, the power of this term, of this variable x in this term is 3. Next term minus 7x. Now here the power of x is 1, right? Because we know that x to the power 1 is equals to x, which means in this term the power of x is 1 and minus 7 is the coefficient of x. Next term, here the power of x is 0, right? Because we know that any rational number with power 0, the value is 1. So we can write 5 into 1, and in place of 1 we can write x to the power 0, which means this expression, the first term, the power of x is 3, the second term, the power of x is 1, and in the third term, the power of x is 0. So the highest power of the variable x is 3. Okay? Now, next expression, here 2a cubed minus 6a minus 9, which means this expression, in this expression our variable is a. Now constant term, here the constant term is 9 minus 9. Okay, we have to write this minus. Minus 9 is our constant term. Next, the power 4, minus 6a and minus 9. So 1, 2, 3. So the number of terms is again 3. Next, we have to find the highest power of the variable. So, first term, the power of a is 4. A to the power 4. Know that here a is base and 4 is a power or index. So, in the first term, the power of a is 4. Next term, the power of a is 1. And in the third term, the power of a is 0. Which means the highest power of the variable a is 4. Next, 2y cube minus 5. So here y is the variable. Now 5 is our constant term, but you have to consider minus 5. Next, the coefficient of the first term y cube is 2. Now, number of terms. So here we have only 2 terms. Right? Now, look at the first term. The highest power of the variable is 3. Y cube. So here the power of y is 3. Next, again 0. So highest power of the term between 3 and 0 is 3. Now, have to study what is the degree of this expression. The degree of this algebraic expression is the highest power of the variable. So, in this expression, the highest power of the variable is 3. Right? Highest power of the variable is 3. Which means the degree of this expression is 3. Okay? Next expression here, the highest power of the variable is 4. Which means the degree of this algebraic expression is 4. Next case, the highest power of the variable is 3, right? So, again the degree of this expression is 3. We can call it as the degree of this expression, of this algebraic expression is 3. So here, now exercise 6.1. First, question number 1. Write the numerical coefficients of each term. So here, first one, minus 5x squared y squared. So here, minus 5 is the constant and x square y square are variable, right? Now next case, here 3 is constant, right? And y square z is the variable of this expression. Next here 7 is the numerical constant and m square are variable. Or we can write it as 7mn square. So the variable is mn. In this case also, here the variable is yz. The power of y is 2. Now in this case, the degree of this expression will be y square z, right? So the power of y is 2. And the power of z is 1. Now add these two powers, which is 2 plus 1 equals to 3. Which means the degree of this expression is 3, or the power of the variable is 3. Okay? So here the power of m square, if the variable is mn, then the power is 2. But in this case, the power is 2 plus 2 equals same, right? So in this case we have to add these two powers, which is 3. So the power of this expression is 3, or power of this term is 3. Now look at here, question number 2. Here write the constant terms in each of the following. Constant term means the coefficient of x to the power 0, right? So here our expression is 5x cubed y plus 7. 7, or we can write it as 7 into x to the power 0. So here 7 is our constant term. Now here minus 3 a square b square c square, which means you can write this expression as minus 3a square b square c square plus 0. Okay? So in this case the constant term is 0. Okay? Because if we multiply any rational number or any rational value with 0, we'll get here 0 only. Right? So we can write 0 into x to the power 0, which means 1. We know that 0 into 1 is equals to 1, right? 0 into 1 is equals to 0, right? So here 0 is our constant term. Now here we have to identify monomials, binomials and trinomials. We know that if an expression has one term only, then we call this expression as monomial. Next, if an expression has two terms, then this expression call it as binomials. And if an expression has three terms, then those are known as trinomials. Now here, in this expression, we have two terms, right? Minus 8x square and y square, which means two terms. So this is it. We can call this expression as binomial. Next, minus 7 only, which means the constant term, only the constant term, minus 7. So again, one term, so we can call it as monomial. Next, in this term, 14x square plus y plus in this term 14x square plus y plus a. So here first term is 14x square, next y, and then a. So here a is our constant part. Okay? So which means here we have three terms. So you can call it as trinomial. If here the variable is x and y, okay, and assume a as our constant term. So in this expression again have only one term, minus 5x squared y squared z squared, right? So again one term. So this is a monomial. Now look at here these two expressions. Suppose x square plus 2x plus 3. Consider another algebraic expression. X square y square plus x y square plus x square y plus x. So in this case, the degree of this expression is the highest power of the variable. So here, among these three terms, the highest power of the variable is 2, right? Which means the degree of this expression is 2. But in this case, consider the power of these terms as, first consider each of the terms. First term x square y square. Second term x y square. Next x square y. And the fourth term is x. Now power of this first term is power of the first variable plus power of the second variable, which is 2 plus 2, 4, which means the power of this first term is 4. Next, here the power of the first variable is 1 plus power of the second variable is 2. So 2 plus 1, 3, which means the power of the second term is 3. And next, 2 plus 1, again 3. And last here, the power of x is 1. So among these 4 terms, the highest power of the variable is 4, right? Among 4, 3, 3, 1. 4 is the highest power, which means the power of this expression, power of this algebraic expression is 4. Okay? Is it clear? Now, here, identify the following expression on the basis of the number of terms and write the degrees of each. Now consider the first expression, 5a square plus b square c square plus 7. So here have 3 terms, right? First one is 5a square, second one b square c square, and third one is 7, which means here the number of terms 3. Now look at here. This is an expression of 2 variables. Sorry, 3 variables A, B and C. Here 5, 1 and 7 are the constants and A, B, C are the variables. Now power of the first term 2, because they are only the first variable. The power of the first variable A is 2. Now consider the second term, b square c square. So again the power of b is 2 plus power of c again 2. So 2 plus 2, 4. Next, here constant term, power of the constant term is 0. Know that, right? Because you can write it as 7 into x to the power 0, or here 7 into a to the power 0 or b to the power 0. So the power of the constant term is 0. So among 2, 4 and 0, 4 is largest, right? Which means the power of the degree of this expression is 4. Degree of this expression is 4 and number of terms 3. Next, 9a square bc. So here this expression has only one term, 9a square bc. So which means the number of terms is 1. 2a plus 3. Now this is an algebraic expression of single variable. Here a is the only variable. So consider the highest power of a, which is 2, which means the degree of this algebraic expression is 2 and number of terms 1, 2, 3. Now here find the value. Next question, find the value of this expression. Okay? Where x is equals to 2 and y is equals to 3. Now look at this expression. If we put the value of x and y in this expression, it will get difficult for calculation, right? So look at this expression, x cube plus 3x squared y plus 3xy squared plus y cube. We know that formula of x plus y cube is equals to x cube plus 3x squared y plus 3xy squared plus y cube. So you can write equal to x plus y whole cube. Now put the values of x and y. So value of x is 2 plus value of y is 3. So 2 plus 3 cube. 2 plus 3 5 cube. Now here 5 is the base and 3 is the power or index. Do you know that 5 cube is equals to 125, right? So this is our answer, 125. So next day we will learn the subtraction and addition of two or more algebraic expressions. So that's all for